Why does a rocket lift off by pushing gas down, not up? The answer is in the same three laws that explain how any push or pull actually changes motion. This video builds them from scratch, starting with what a force even is. A force is a push or pull that can start, stop, or change an object's motion, or change its shape. When several forces act on an object, only the net force matters. In a tug of war, if both teams pull equally, the forces are balanced, and the rope doesn't move. If one team pulls harder, the net force acts in their direction. For forces in the same direction, you add them. For opposite directions, you subtract, and the net force follows the bigger one. Newton's first law says an object's motion doesn't change unless a net force acts on it. A body at rest stays at rest. A moving body keeps moving at constant velocity. A rolling ball doesn't stop because motion naturally runs out. It stops because friction, the force opposing relative motion between surfaces, acts on it. Without friction, it would keep moving forever. This resistance to a change in motion is called inertia. Newton's second law makes this precise. Force equals mass times acceleration, F equals ma. For the same object, a bigger force gives bigger acceleration. For the same force, a bigger mass gives smaller acceleration. A 25-kilogram block pushed with a net force of 5 newtons accelerates at 5 divided by 25, which is 0.2 meters per second squared. And weight itself is just the gravitational force on an object, F equals mg, where g is about 9.8 meters per second squared near Earth's surface. Newton's third law says whenever one object pushes or pulls a second object, that second object pushes or pulls back equally and oppositely on the first object, a different object. So these forces never cancel each other out. A rocket pushes gas downward. By the third law, the gas pushes the rocket upward with equal force, and if that exceeds the rocket's weight, it lifts off. For two connected objects pulled by one force, treat them as a single system. Acceleration equals the force divided by their combined mass, ignoring the internal forces between them. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Forces of 10 newtons and 6 newtons act in opposite directions on a block. The net force is the larger minus the smaller. 10 minus 6 equals 4 newtons in the direction of the 10 newton force. The answer is 4 newtons. Only the net force changes an object's motion. Newton's first law says zero net force means zero change in motion. The second law gives F equals ma, and the third law means every force has an equal and opposite partner on a different object. Free notes in the description. Subscribe to Clarix for the rest of Class 9 Physics.